Let m be the least common multiple of all the integers 10 through 30 inclusive. Let n be the least common multiple of m, 32, 33, 34, 35, 36, 37, 38, 39, and 40. What is the value of n over m? Since we know that m is the LCM of the integers 10 through 30, let's look at what it would be. We know that it's going to be a product of powers of primes. So let's see what the highest power of every single prime number is for these integers. We notice that the highest power of 2 less than equal to 30 is going to be 2 to the 4th, which is 16, because we know that 2 to the 5th is greater than 30. We also know that we have 2 to the power, 3 to the power of 3 is less than equal to 30, which is 27, and it's less than 3 to the 4th. For 5, we consider 25, which is 5 squared, and we know that is the greatest. And then we see 7. 7 to the first power is 7, whereas 7 squared is too big already. That means all the other prime numbers greater than 7 will reflect these same conditions as 7. So we can write m as 2 to the 4th times 3 cubed times 5 squared times 7, 11, 13, 17, 19, 23, and 29. 29 is the greatest prime that's still less than 30. So then we realize, okay, this is m. Now, how can we write n? N is known as the LCM of m and all these numbers to 40. We notice that that means we just have to find some numbers that are in n but not in m, or powers of primes in n not in m, multiplied by the prime factorization of m. Let's first look at what this is. First off, we realize that the power of 2 has changed. Currently, the fifth power of 2 is included in 32. So that means we have an extra power of 2. We also realize that, okay, 3 to the 4th is 81, that's still not included. 5 cubed is not included, etc. We continue on to realize that none of the primes have an increased power in the existing primes already. But now let's look at if there are any prime numbers between 32 and 40 inclusive. Well, we note that there actually is a number, and that is the number 37, which is prime. So since this new prime has been introduced, we can add that to our prime factorization. So our new prime factorization now contains an extra power of 2 as well as 37. Therefore, if we write it out, we notice that n is then equal to 2 times 37 times m equals 74 times m. Now, if we look for the value of our fraction, n over m, that gives us 74m over m, which equals 74, and that is answer choice D.